second modulation technique is FSK, that is frequency shift keying. Definition of FSK: the frequency of carrier signal is varying with respect to amplitude of message signal. So modulation of FSK or FSK modulator. In FSK, the binary information can be transmitted through a carrier signal along with the frequency changes. Figure 4, it shows the block diagram of the FSK modulator or frequency shift keying block diagram. In FSK, two carrier signals are used to produce FSK modulated waveform. The reason behind this, the FSK modulated signal are represented in terms of two different frequencies. The frequencies are called mark frequencies and space frequency. The mark frequency, it represented logic 1 and space frequency represented logic 0. There is only difference between these two carrier signals, that is carrier input 1 having more frequency than the carrier input 2. Means carrier input 1, it has high frequency than the carrier input 2. In this, the switch S of 2:1 multiplexer is having the important role to generate the FSK output. Here the switch is connected to carrier input 1 for all logic 1s of the binary input sequence, and switch S is connected to carrier input 2 for all logic 0s of the input binary sequence. So the resultant FSK modulated waveform have mark frequencies and space frequencies. The figure 2.5, it shows the waveform of FSK. In this, input 1 is the high frequency carrier signal, input 2 is the low frequency carrier signal, and at switch gives binary sequence, that is 1 1 0 1 0 1. If binary input is 1, then switch S, it switches to carrier frequency at input 1, that is high frequency carrier signal, and if binary input is 0, then it switches to low frequency carrier signal, and at the output, according to switching, we get the frequency changes. So it is frequency of carrier signal varying with respect to amplitude of the message signal. Then demodulation of FSK. So again it is two types of demodulation, that is asynchronous and synchronous. So it is synchronous FSK detection. It is affected by noise while reaching the receiver. So this noise can be eliminated from using the bandpass filter. Here at multiplier stage, the noisy FSK modulated signal is multiplied with the carrier signal from the oscillator device. Then the resultant signal, it passes from the bandpass filter. Here this bandpass filter is assigned to cutoff frequency which is equal to the binary input signal frequency. So the same frequencies can be allowed to the decision device. Here this decision device gives 0 and 1 for space and mark frequencies of the FSK modulated waveform. So here we get at the demodulation of FSK reconstructed modulating signal. Then advantages of FSK. First, simple process to construct the circuit. Second, zero amplitude variation. Third, supports a high data rate. Fourth, low probability of error. Disadvantages, it requires more bandwidth than the ASK and PSK, that is phase shift keying. Second, due to the requirement of large bandwidth, this FSK has limitation to use only in low speed modems, which the bitrate is 1200 bits per second. Then applications, useful in high frequency radio transmission, preferable in high frequency communication, low speed digital applications. In telephone line modem used FSK to transmit 300 bits per second at 1070 Hz and 1270 Hz. Thank you.